Hello friends. Welcome to T Academy. We'll continue the previous AE electrical question papers. In my previous video, I already discussed the network subject, in which we have discussed a few questions that are asked in the previous AE paper. Now let's continue the AE paper solutions. In this video, I am going to take up the control system subject. In this subject, you are going to see different concept-based questions here. Among them, one of the very important common type questions that you can see in any examinations, especially in PSU such as A examinations, you will see that there must be one question based on RH criteria. There must be at least. Okay, so we'll see that this kind of questions here. For the system s cube minus 4s square plus s plus 6 is equal to 0, state how many roots are in the right of s plane. So here in the question, the examiner is asking that how many poles are there in the RHS of the S plane here. So based on the RH criteria, what we will do is we will take this S cube and S square, S power 1, S power 0. Okay. So as per the concept, how many sign changes, that is a plus to minus or minus to plus, how many sign changes are there, that much number of poles are lying on the right half of the S plane here. I will explain it. So s power 3 first I will take, so it is a 1. Okay, and here s, so we'll take only odd values here, and here we have minus 4. Okay, here plus 6. Now we need to do cross multiplication here. So for that one, what I'm doing is I'm just taking here some values called x here. So what is the value of x, sir? X is nothing but cross multiplication of minus 4 into 1. So minus 4 into 1. Again cross multiplication of minus 6 into 1 divided by, what's the value? Minus 4 here. So if you solve this here, minus 10 by minus 4, which is nothing but it's a simply 2.5. So here you need to focus on the sign value, not the value. Okay, not 2.5, but it should be plus 2.5. So x value will be what? Plus here. Okay, so here minus 4 means it's a minus, and here we have plus means plus here. That's it. Now, so here what you'll get is, here you will get is 0 here. Now again here, what is the value? So we'll take y here. So y is nothing but cross multiplication of this first x into 6. Okay, so I'll write 6 into 2.5. X value we know, that's 2.5. Okay, so minus of minus means plus 4 into 0 divided by, what is the x value? 2.5. So finally you're getting answer of 6. What about the sign? Plus sign or minus sign? Plus. Okay, sir, plus here. Now understand here, how many sign changes are there? So first we have plus 1, and here we have minus, that is a one sign change here. Okay, one sign change is there. Okay, now from here minus 2, again plus, again it is changing. So here we have second sign change here. Okay, here you have first sign change, and again next we have second sign change. Okay, and see here, here plus to plus, is there any sign change? So no sign change here. So how many sign changes are there? There are two sign changes, means this much of poles lying on the RHS. Okay, so as per this concept, the answer will be 2 here. That must be two poles lying on the, or two roots lying on the RHS, and one on the LHS. So what is the stability of the system? Is it stable? No, it is a unstable system. Unstable system here. So unstable system here. Okay, right. Unstable system. So answer for this question is a 2. So let's move to the next question. Now here, the transfer function of lag lead compensator is, okay. So here you need to understand some few basic points here. So in the S plane, let's take here. So let me choose different color for that identification purpose. Right. Okay. So first, lag means there should be a pole. Okay. So let me correct here, pen here. Okay, there should be pole. Okay, sorry. Okay, there should be a pole, After that this will be 0. So this will constitute what? It is a lag. For lead there should be a pole, no, there should be a 0 and pole here, so this should be lead. So I'm repeating here. So for a lag compensator, so lag to dominate, there should be a pole here, and after that there should be a 0. Okay, for lead compensator there should be a 0. After that it should be a pole. So this is the concept here. Okay, so here this typing mistake is there. Let me take here T1 here. Now who is going to lead? Who is going to lag? So this parameter is there. So this entire parameter is going to act as a lag compensator, and this entire parameters are there. This will be act as a lead compensator. So I will draw this pole diagram here. See, S-plane diagram here. So I'll try to connect different pins, but I'm not able to. Okay, let me see here. Yeah, okay. So as per this concept, so who is going to be first here? So there should be a pole. So pole should be there. What are the poles here? We have two poles are there. What are the first pole? That is minus gamma by T1 is a pole. Okay, and minus 1 by beta 2 is a pole. So these two are the poles. So these two are the poles. What about the zeros? So zeros what we have? So minus 1 by T1 and minus 1 by T2. These two are the poles. As per this concept, who is going to first focus? So this one will be pole. So what's a pole here? Here we have pole minus gamma by T1. Okay. After that pole. What's the pole? 0 minus 1 by T1. After that 0 minus 1 by T2. After that pole means minus 1 by beta T2. So this is the uh, plane here. Now choose a different values here. So if the pole should be here nearer to the origin means what about the gamma value? Gamma value it should be less than 1, so that it will be nearer. Suppose if gamma is greater than 1, so it will move towards this area. Okay, so move towards the left. Okay, so the gamma values are more and more, it will move towards the left, so that is not the criteria. So gamma should be less than 1. This is the one condition satisfied. Next one, beta value, see here. So if the beta value is less than 1, what will happen, sir? So it will move towards the left side like this. So it is also satisfies the condition. Suppose its beta is greater than 1, so 1 by beta will be lesser, no? So as a lesser values are there, so it is going to move to the RHS side. So that is not the condition here. So the concept is the gamma value should be less than 1, so that here we will have a pole, and beta value is less than 1, so that this denominator part here it should be more value, so that the pole is moving towards the left side. So left side, so that as per these conditions the gamma and beta value both should be less than 1. So answer is D for this question here. So I hope you understand this logic. We'll move to the next question here. Okay, right. Now this question is from the root locus. That is, the system is having GC of S, H of S is equal to K into S plus 0.5 divided by S into S square plus 2S plus 2. To draw on the root locus, the centroid is. So here we need to find the value of centroid here. So first we will write the formula for the centroid. After that we will discuss. So centroid. So centroid sigma is equal to, right? So its meaning is sum of real part of poles minus sum of real part of zeros. So understand this, what's the real part here? So that is a logic in this question. Okay, the simple question only, but here you understand what is the real part of these poles and what is the real part of real part of zeros here. Okay, now after that in the denominator part, number of poles minus number of zeros here. Okay, so we know that there are three poles are there. Okay, so what are the First one s is equal to 0, and second one is s square plus 2s plus 2. So we need to solve this and we need to find the poles here. So what are the poles here? So we'll apply the formula. So minus b plus or minus square root of b square minus 4ac by 2a. I will apply the formula here. So minus 2 plus or minus square root of b square means 2 square minus 4 into a is 1, b is a 2 divided by 2 into 1. If we solve this, we will get the answer as minus 1 plus or minus j, like this you will get. So one pole is s is equal to 0, remaining two poles are minus 1 plus j, another pole is minus 1 minus j. So these are the three poles you got here. So three poles. What about the zeros, sir? So zeros. What are the zeros here? 0 is nothing but s is equal to minus 0.5. So this is the poles and zeros. Now apply the formula. Centroid. Centroid sigma is equal to sum real part of poles. Sum of real part of poles means what are the poles? I have 0. Real part means I will consider this one only. I will not consider this part. So I will take here minus 1. After that minus 1. So these two poles are now. So pole number 2 here and pole number 3 here. So this is the pole number 1. So 0 minus 1 minus 1. Next, minus of real part of zeros. How many zeros we have? Only one zero. So minus 0.5 divided by how many number of poles? There are 3 poles and number of zeros are 1. So 3 minus 1 is equal to minus 2 plus 0.5 divided by 2. So if you solve this, you'll get it as a 1.75. No, it's not like that. So minus 1.5, 1.5. Okay, so later on minus 1.5 divided by 2 minus 0.75 will be the answer. So answer here it is D is the right answer for this question here. We'll move to the next question. Okay, so this is the question that is asked in controllers, right? The integral controller enhances the steady state response, dynamic response, no effect of the controller, transient response. So integral controller, what it will do is it is going to decrease the steady state error. So integral controller, it is going to decreases steady state error, ESS we know. Okay, so this is also very, very important concept. So it is going to decrease the ESS value. Hence, it is going to improve what? It is going to improve steady state stability. So it is going to decreases the ESS value. Okay, so it is going to improve the steady state stability. So steady state stability is inversely proportional to ESS. Okay, so answer for this question will be it is going to improves or enhances the steady state response. Okay, it is going to reduce the steady state error also. Okay, next one. The PID controllers are tuned on the frequency response of the closed loop system by. So the transfer function of this PID controller will be given as GC of S is equal to so Kp plus K T by S plus Kd into S here. Okay, so the PID controllers are tuned on the frequency response of the closed loop system by using the open loop gain corresponding to marginal stability. Answer for this question will be A. Next, we'll move to the next question here. Right. So in this question, the transfer function is given. The transfer function given as 25 divided by s square plus 6s plus 25. Here we need to find the value of peak time in seconds here. So for that, first we need to compare this transfer function with the standard equation, that is of second order system is omega n square divided by s square plus 2 zeta omega n into s plus omega n square. So from this, by comparison, we can say that omega n is nothing but 5 and 2 zeta omega n is equal to 6. So substitute the value of omega n here. So zeta will be equal to 6 divided by 5 into 2, it will be 0.6 here. Okay, now what is a peak time formula here? That we need to keep in mind. That is peak time Tp is equal to pi divided by omega d. Okay, so which can be also written as pi divided by omega n into square root of 1 minus zeta square. So here you know the value of zeta and omega n value. This directly you need to substitute here. Okay, that is nothing but, so pi value is 3.14 divided by omega n is nothing but 5 square root of 1 minus 0.6 square here. Okay, so from this, so 3.14 divided by, so 5 into square root of 1 minus, so it is going to be 0.36. So again simplify this so that you will get 3.14 divided by 4 here. So approximate answer will be less than 1. So among the options there are two options are there. So approximate answer will be 0.785. So answer will be A for this question. That's it for this session. Thank you friends. Have a nice day.